Can you hear me now? Is this working? Can you guys hear me now? Yeah, still working fine? I think I have, yes, problem with the remote of my AC. Crazy, right? All right, how about, yeah, okay, it's still working. Good. I'm not touching anything. No. Okay. All right. Again, of course, if at any stage it seems like the mic is off, just to type a message as soon as you can. So I stop, I reset my mic, and we can keep going. All right. So I was, of course, welcoming you all and was saying that I was hoping that you had a nice day. No, that's everyone, it seems. I hope you still have some energy left for me tonight. I still have some energy for you. Yeah, it seems like most participants would rather simply watch the video recording, and this is fine. But I want to thank you guys for attending live, simply because it makes it, it's just more, it's just better for me. Okay, I would not really enjoy to just do this alone, and it's way more enjoyable for me to be able to know that you are there live and that you are there's so I can answer any question that you may have right away. So again, thank you very much. I realize that many of you had a long day, but thanks for making the effort and joining this workshop live tonight. So tonight we are only going to look at one PPT, one topic, but it's a big topic because we are going to talk about elasticities. And there are 4 different types of elasticities that your students must be familiar with. There are 3 demand side, you can call them this way, 3 demand elasticities, PED, XED, YED, and 1 elasticity of supply, the PES. So we need to know what they are, what they mean, the relationship that they can have with other economic concepts, what can influence their value, and so on. To give examples, calculation, and everything. So there is a lot to do. I have already shared the documents on the website, almost all of them. So the PPT is already available. The teacher's version, the student's version. I have also uploaded the concept cards. Okay, all the concept cards about elasticities. I have also uploaded the definitions. Okay, all the definitions that relate to elasticities. So there is something missing, which is the summary. I have not had enough time to prepare a summary about elasticities. So this is something that I'm going to work on tomorrow and the rest of the week. So I will post a message as soon as all the resources are available on the website. But at least you have the PPT, the summary, the definitions. That's a good start. Okay, shall we? Let's get started with elasticities. So in fact, I don't like to start right away with the PED. I know that in most books, they just start right away with the PED. I like to start with an introduction to elasticities because when you think about it, all elasticities, they work the same way. And the formula is the same, and the way you interpret the sign is the same, the way you interpret the value If it's close to 0, if it's big, is the same. So I'm afraid that if you start talking directly about the PED, then your students will not really realize that those different types of elasticities, they really work the same way. So that's why I like to start with something that I call introduction to elasticities, where I try to give a more, to follow a more general approach of elasticities. And you will soon understand why I have decided to include that particular picture in an example. So generally speaking, an elasticity, it's a measure. It's a measure of the relationship between two variables. Okay, could be anything, and we calculate elasticities in economics, but also in physics, in biology, in probably chemistry. So this is not something that only belongs to economists. Of course, you have two variables. You suspect that there is some relationship between the two, and especially a cause and effect relationship. Okay, so you will change one, and as a result, the other will change. So as soon as you have this causal relationship, you can calculate an elasticity. Okay, so you change the value of one variable. Okay, let's say we change the variable, the value of variable y. Oh, sorry, we change the value of the variable x, and we look at, okay, what is the consequence on, or what is the impact on the value of the variable y? Could really be anything. Okay, we give names, and if you remember in the first chapter when I talked about economic models, I explained what is the difference between an endogenous and an exogenous variable. We also sometimes call that dependent and independent variable. But essentially, what you can keep in mind is that the independent variable explains or causes the dependent variable. Okay, so to simplify, the independent variable is just the cause, and the dependent variable is the consequence. Okay, so you will change the independent variable, and you will see what happens to the dependent variable. Okay, that's essentially what we do when we calculate an elasticity. So yes, the dependent variable is explained by the independent variable. Okay, so for example, in the case of the PED, you have two variables, price and quantity demanded. Well, of course, you can't really say that it's the quantity demanded that explains the price. Okay, it is the price that explains the quantity demanded. So in that case, the price would be the independent variable, and the quantity demanded would be the dependent variable, the explained variable. Okay, so yes, there is a causal relationship. One cause leads to one consequence. So if we use examples from physics, for example, I hope you have good memories from your physics lessons. The weight of a body is explained, cause if you want, by its mass and by the gravitational force acting on the body. Yeah. Energy is explained by power and time. You cannot say that the weight of a body, or you cannot say that the gravitational force is explained by the weight of a body. Okay, so I really feel like this is something that is often not made very clear in books when we look at elasticities. Yes, it's two variables, but it's usually one that explains the other, or one that causes the other. Okay. And that's why I really want to make this general introduction, because the formula is actually the same for all elasticities. It's always the percentage change of the dependent variable over the percentage change of the independent variable. So if you really want to keep it simple, that's sometimes what I do. I just say that it's the percentage change of the consequence divided by the percentage change of the cause. Okay, to keep this in mind. And you see, this works for the PED, for the PS, XCD, YED. So it always works. They don't have to remember 4 formulas. for each type of elasticity. Honestly, if they remember this one, if they understand this one, it's done. Okay, then they simply have to replace, okay, in this case, what do we explain and what is the variable that explains it, and that's it. End of story. So yes, this symbol there, percentage delta, is the symbol that we use for percentage change. Okay, and this is how we calculate it. This is the formula: new value minus old value divided by old value times 100%. Sometimes to remember, we use the no, N-O over O. So it's like N minus O over O. So it's like N slash, not slash, like, yeah, O. Well, I think all your students, they should know how to calculate the percentage change. What is also important, because it's a typical mistake that they make, is an elasticity is dimensionless. It doesn't have a unit. Okay, many students, after they have calculated an elasticity, they tend to write a percent, to express it as a percentage. No, it does not have a unit. Okay, it just could be 1, 2, minus 1, minus 10, but it is not a percentage. It's important to keep this in mind. And of course, the relationship between two variables varies on the basis of the value taken by the independent variable. For example, in the case of the price elasticity of demand, you know that its value changes as we move down the demand curve. If you have a demand curve that is a straight line, the PD is not constant. So it's important to keep this in mind. Now, the value of the elasticity depends on where it is measured. By where, yes, that means for what values. In the case of the PD, it depends on the initial price and the final price. If you take two pairs of prices, like an initial price and a final price, it's likely that the value of the elasticity, the value of the PED that you will find, will be different, unless you have an isoelastic demand curve. But let's not consider that case. So yeah, it's important to keep this in mind. And then once we know what an elasticity is, there are essentially two things that we need to consider once or after we have calculated an elasticity. The first thing that we have to consider is the sign, whether it's positive or negative. And the second thing is the value. Is it very large in absolute value? Could be very positive or very negative, essentially. Or is it close to zero? Could be like close to zero, like minus 0.1 or 0.2, something like that. Let's first look at the sign and let's see what information it gives us, because it gives us an information. If you end up with an elasticity that is positive, this means that your two variables, variable x and variable y, they are positively related. Positively related, yes, simply mean that they move in the same direction. So if you increase one, the other is going to increase. If you decrease one, the other is also going to decrease. The two, they move in the same direction. And in this case, it's clear if you look at the formula. If both increases, then the ratio is positive, and if both falls, negative over negative, this is also positive. Okay, so yes, this tells us that there is a positive relationship, just like between price and quantity supplied. However, if you find that an elasticity is negative, this means that there is a negative relationship between the two. We also call that an inverse relationship, just like the relationship between price and quantity demanded. If you increase one, the other decreases. If you decrease one, the other increases. Okay, quite simple, pretty simple. So yes, you should stress that looking at the sign, for now, it doesn't matter if it's big, if it's a 2, 3, 4, 5, it doesn't matter. What matters is it's positive. So it gives us information about the nature of the relationship. But then once we know whether we are dealing with, whether we have a positive or negative relationship between the two variables, we can wonder how strong the relationship is. Is this like a weak relationship, or is this a very strong relationship? And if we want to answer that question, we must have a look at the value of the elasticity. So yes, it tells us how sensitive, how responsive the dependent variable is to a change in the independent variable. This is what essentially the value of the elasticity measures the intensity of the relationship. And if you and we have names, okay, I don't know if these are economists or physicists, but we have given names for different degrees of sensitivity, essentially. If the elasticity in absolute value, because we could be positive or negative, but here it doesn't matter, we take the absolute value of the elasticity, and if it is larger than 1, then we say that the dependent variable is elastic with respect to the independent variable. What does it mean? This simply means that, okay, there is a strong relationship. This means that the dependent variable varies a lot if we change the independent variable a little. Okay, so the dependent variable is very responsive, very sensitive to changes in the value of the independent variable. And in particular, this means that if you change the independent variable by, let's say, 10%, this means that the dependent variable will change by more than 10%. So there is a more than proportional change in the dependent variable. It's important to remember that we are always talking about proportional changes in percentage. And it's easy to see here, right, that your elasticity is going to be greater than 1 if the percentage change in the dependent variable is greater than the percentage change in the independent variable. Okay, it doesn't matter if there is a positive or negative relationship. In both cases, you will end up with an elastic dependent variable. However, we can have the other case. If you end up with an elasticity, again, measured in absolute value, which is smaller than 1. So same thing, if you look at that, smaller than 1, this means that the denominator is greater than the numerator. So for example, if you change the independent variable by 20%, perhaps the dependent variable is only going to change by 10%. So it is not very sensitive, it's not very responsive to changes in the independent variable. So essentially, this means that the relationship is relatively weak. Okay, and we say that the dependent variable is inelastic, relatively inelastic with respect to the independent variable. Okay, and then there are two extreme cases that doesn't really happen often in reality, but these are theoretical cases. The first one would be where you have perfect elasticity, which would mean that if you change the independent variable just a little bit, then the dependent variable will change a lot. Actually, there will be an infinite change in the dependent variable. This is what this means. So for example, again, if we look at this formula, this would be a case where you change the independent variable by, I don't know, 0.001%. And as a result, the dependent variable changes by, I don't know, 1,000, 2,000, 3,000%. Okay, this would be something like that. Something very big divided by something very small. The elasticity would be very, very large. It would tend towards infinity. So that's one possible case. And the last extreme case would be perfect inelasticity, which essentially means that there is no relationship between the two variables. So you can change the independent variable as much as you want, and this will have no impact, this will have no effect on your dependent variable. Okay, in that case, the elasticity is equal to 0. Okay, so same thing, let's have a look at the formula. We change the independent variable as much as we want. Okay, it could be, let's say we double it, so 100%. The dependent variable will not change at all, 0% percentage change, and therefore the elasticity is equal to 0. Okay, so in that case, there is just no relationship between the two variables. Okay, so you see that this is very general, but that's great because it really you can apply all this to all elasticities. So very general, but I think that's a pretty good introduction to make sure that your students have a first grasp at the concept of elasticity without being too specific. I have also added information about a last case, which is a very special case, where if you have unit, if the dependent variable is unit elastic with respect to the independent variable, so this would be the case where the elasticity is exactly equal to 1. So the only case where the elasticity can be exactly to 1 is if the percentage change in the dependent variable is the same as the percentage change in the independent variable. Okay, remember, independent variable is the cause, dependent variable is the consequence, to keep things simple. And of course, if the percentage changes are the same, then the elasticity is equal to 1. That makes sense, no problem. Okay, and to conclude this introduction, I have created an example, and this is right now that you will understand the picture that I have displayed at the beginning of this section. So we are interested, so this is not related to economics, but this is, we're going to calculate an elasticity no matter what. I'm actually interested between the relationship between the water's boiling point, which is the temperature at which water will boil, of course, and the atmospheric pressure. And well, we know that there is a positive relationship between the two. If you increase atmospheric pressure, so for example, if you lower your altitude, then the water's boiling point is going to increase. So for example, at sea level, it's around 100 degrees Celsius. But if you increase your altitude, atmospheric pressure decreases, and then the water's boiling point is actually decreasing. Okay, so low atmospheric pressure, lower water's boiling point. So here, same thing. The first thing that we should think about is, okay, when I have these two variables, which one causes the other? Is this the water's boiling point that causes the atmospheric pressure, or is this the atmospheric pressure that causes or explains, maybe better to say explains, that explains the water's boiling point? And of course, it is that case. Okay, it is the atmospheric pressure that explains the water's boiling point. So the atmospheric pressure is our independent variable, okay, the cause, and the water's boiling point is our dependent variable, the consequence. Okay, and then I give some data, and actually I looked at the real data, so we can do it for real. I took two cities in China, so Chengdu, capital of Sichuan province, and Lhasa, capital of Tibet. So I give you the average altitude of each city. And therefore, you can actually also calculate the average atmospheric pressure. Okay, so you have here the average atmospheric pressure in Chengdu is relatively high because the altitude is relatively low. And here we have the average atmospheric pressure in Lhasa. It's much lower because the altitude is much higher. Okay, and of course you see that as a result, the water's boiling point is much lower in Lhasa than in Chengdu. And again, this is the real data. So then, with this information, we could actually calculate an elasticity. But of course, we need to know the direction of the change. So essentially, do we travel from Chengdu to Lhasa, or do we travel from Lhasa to Chengdu? We'll need this. And of course, okay. The water's boiling point is explained by atmospheric pressure. Okay. So let's just pretend that we travel from Chengdu to Lhasa. So I can calculate the percentage change in atmospheric pressure. Okay, the new atmospheric pressure in Lhasa minus the current or the old atmospheric pressure in Chengdu divided by the old atmospheric pressure times 100%. Boom. All right, so when traveling from Chengdu to Lhasa, the atmospheric pressure has decreased by 32%. Okay, and I can do the same thing, calculate the percentage change in water's boiling point when traveling from Chengdu to Lhasa, use the same formula, and I find that it has decreased by nearly 11%. And I just have to use the formula, percentage change in the dependent variable. So here the dependent variable is the water's boiling point, divided by the percentage change in the independent variable, which is here atmospheric pressure. And I get my elasticity, 0.34. So there are two things that I can say now. First, I see, oh, it's positive. I have a positive elasticity, so this confirms that we do indeed have a positive relationship or a direct relationship between the two variables, between atmospheric pressure and the water's boiling point. That's the first information. The second information that I have is that I see that this elasticity is less than 1, which means that the water's boiling point is not very sensitive to changes in atmospheric pressure. Okay, we can say that the water's boiling point is relatively inelastic with respect to changes in atmospheric pressure. And we can see that, right? We have decreased the atmospheric pressure by over 30%, but the water's boiling point has only decreased by 11%. So it does not change much, basically, relatively to the change in the independent variable. So that's what we can say, positive relationship, relatively inelastic. And we can even try to make these numbers talk. If the elasticity is equal to 0.34, this means that every 1% of atmospheric pressure that we lose when traveling from Chengdu to Lhasa leads to a 0.34% decrease in the water's boiling point. Okay, and I think it's important to show an example and to connect different subjects. You know, there are not so many occasions, there are not so many opportunities for us to connect economics with other subjects like physics, biology. Here we have that opportunity. So that's why I really wanted to have an example of to start introducing elasticities with something that is not economics. Your students have studied physics. Maybe you have maybe your physics lessons are a bit far in your distant in your memory, but I'm sure they know that they know how this works. So I think this is a good way to engage them and to connect their physics class and their economics class. Okay, all right, and then we are ready. Then we can have a look at the 4 main elasticities that are often used or usually used in economics: the price elasticity of demand, the cross price elasticity of demand, the income elasticity of demand, and the price elasticity of supply. And I have actually made that list right now because then you can tell your students, look, they are the same. They are exactly the same. This works exactly the same. The only thing that we have to wonder is, all right, what is the independent variable? What is the cause? What is the consequence? So in the case of the PED, what is the cause? The price of the product, okay? What is the consequence? The quantity demanded. We change the price and we see what happens to the quantity demanded. Okay. In the case of the cross price elasticity of demand, we change the price of good X, that's the cause, and the consequence is we look at the change in the quantity demanded of good Y. That's the same thing, we just cross 2 products or 2 markets, essentially. Same thing with the income elasticity of demand. What is the cause? What is the independent variable? Income. We change income and we see what is the consequence of that change of income on the quantity demanded. Okay, so income is the independent variable. Quantity demanded is the dependent variable. And finally, the PES is really like the PED, but quantity supplied instead of quantity demanded. Okay, so and the rest should actually be quite easy. If they have understood, if your students have followed this introduction, then everything that we are going to do, not everything, but most of what we are going to do now is just going to be the application of this more general framework. Okay. Do you have any questions up to now? Is this okay? Does it make sense to everyone? Do you think it's a good way to start this lesson on elasticities, a bit more general? Sure, but it gives your students more flexibility. At least that's my view. Rather than simply remembering definitions and formulas, I think it makes more sense to approach the lesson this way. Okay, then we can start with the PED. I have already given the definition. We measure the change in quantity demanded. So that's the consequence when we change the price of the good or service. That's the cause. Of course, the formula is the same as before. We just replace the dependent variable by quantity demanded and the independent variable by the price. Okay, and I can rewrite it. Okay, so QD is QD. The O here means that's the old value. Okay, so that's the initial value if you want. And same thing there. PO is the old price. So delta P is new price minus old price divided by old price. So we do indeed have a percentage change. Delta QD is the new quantity minus the old quantity. Because here I divide by the old quantity, I have a percentage change. So this is how they should actually calculate it. But something that you should really tell them from the start, when they calculate an elasticity, they should do it step by step. Because many of them, they try to do it at once, just without dividing things clearly, and they often make calculation mistakes. So what they should do is first they calculate the percentage change in quantity demanded, okay? Then they calculate the percentage change in price, and finally they can calculate the ratio, okay? But if they try to do the 2 steps at once or 3 steps at once, it's likely to end up with calculation mistakes. Of course, we have studied the law of demand. So the students know that demand curve is downward sloping. There is an inverse relationship between price and quantity demanded. And in that case, as I explained earlier, when there is a negative relationship between the 2 variables, then the PED, the elasticity, is negative. And that's why in some books, they directly work with the absolute value. Okay, instead of saying, okay, the PED is equal to -2, they directly say the PED is equal to 2. This is not a mistake. It's just it's like a shortcut, okay, because we want to get rid of this negative sign. So we just assume that we are working with the elasticity, the absolute value of the PED. So this is actually how we could calculate it. Let's say you have your initial price, PO for all price. At that price, the quantity demanded is QDO. So that's 0.0. And then the price decreases. So this vertical distance is the change in price, delta P, new price minus old price. And as a result, there is an extension of demand, movement down along the demand curve. The quantity demanded rises from QDO, old quantity demanded, to QDN, new quantity demanded. And this horizontal gap here is the change, delta QD, the change in quantity demanded. Okay, so I drew these diagrams so your students have all the different letters, so they can use that to calculate elasticity. So they know what I mean by delta QD, they know what I mean by QDN, things like that. So this is just to clarify a bit. In this syllabus, students are not expected to use the midpoint method. Maybe those who have already taught AP economics, they know that this is something that is often taught in AP microeconomics, but this is not expected. Students are not expected to know these methods in A level, so you can simply skip it. But if you are interested yourself as to in knowing why there is a different method, then feel free to have a look at this. Okay. Same thing, you can skip this. This slide is just there to introduce an alternative definition or an alternative formula of the PED that can actually be very useful if your demand curve is a straight line and if you know the slope of your demand curve. If you know the slope of the demand curve, okay, well, in that case, you can simply use this formula to calculate the price elasticity of demand, and it's very, very quick. I've just rearranged the terms, and I see that here the denominator is just the slope of the demand curve. So for example, if you have this demand curve, and I tell you, okay, I want you to calculate the elasticity when going from O to N, I see that the slope is -4, okay, 40, 10, so the slope is -4. So I just have to take the old price, 28, divided by the old quantity, 3, divided by the slope, boom, and I have my elasticity. So you see, it's pretty quick. But this is only useful if you know the slope of your demand curve and if it's a straight line, okay? In that case, it might actually be useful. Or if you know the slope of the segment that goes from point O to point N. Okay, but you see there is the one step further sign. So I usually do not give this alternative formula to the students, but okay, it's up to you, you decide. All right, and then as we mentioned before, there are several possible cases depending on the value. So the PED is always negative because of the law of demand. Okay, in AS we will not consider the case where the law of demand is not satisfied. So let's just say the PED is always negative. But then it can either be smaller than 1 or equal to 0, smaller than 1, equal to 1, greater than 1, or equal to infinity. And of course, each case has a name. It means something and can be represented in a certain way, but I have already talked about all that before in the introduction, so it's not really necessary to repeat ourselves. You can just say, okay, if the PED is infinite perfect price elasticity, I already explained what this means. If it's greater than 1, price elastic demand, please, please, please. It's not enough to, if the students write the demand is elastic, it's not okay actually. Can anybody guess why it's not okay if the students say the demand is elastic? What might be the problem if you just if in an essay, for example, students say the demand is elastic? There might be some ambiguity. There might be some might be a bit unclear, because something, when you say something elastic, you have to say with respect to what? And there are 3 possible elasticities of demand. It could be elastic with respect to its own price. It could be elastic with respect to the price of another good, or it could be elastic with respect to the buyer's income. So it could be price elastic, income elastic. So it's not clear. So that's why in my PPT, you will always see price elastic when I talk about the PED, just to emphasize that, yes, this means elastic with respect to its own price. Okay, and you should really encourage your students to be precise and to use this term. While I'm at it, there is also something that I really don't like to see in essays, and please tell your students not to make this mistake, because it is a mistake. Very often students, they write when the PED is elastic. What's wrong with that? Why is it wrong to write when the PED is elastic or when the PED is inelastic? This does not make any sense. Can you guess why? To write something like that, the PED is elastic, the PED is inelastic, this does not make any sense. No? No one? An elasticity is a number, okay? Saying that a number is elastic doesn't mean anything. Saying that a number is inelastic does not mean anything. You can say the PED is high, the PED is low. You can say the demand is elastic, the demand is inelastic, but you cannot say the PD is elastic or the PD is inelastic. It just doesn't make any sense. Okay, so please in the essay and remind them to use the proper terminology. So yes, we have the 5 different cases: perfectly price elastic, PD is equal to infinity; price elastic demand, PD is greater than 1. What does it mean? Quantity demanded is sensitive to changes in prices. Unit price elastic, same percentage change in price and quantity demanded in absolute value. Smaller than 1, price inelastic. The quantity demanded is not very responsive. It changes, but there is a less than proportional change in quantity demanded. And finally, when the PD is equal to 0, perfectly price inelastic. You can change the price as much as you want. The quantity demanded will never change. Can students say the product is elastic? No, same thing. A product is elastic doesn't mean anything. The demand is elastic. Or even more better, the quantity demanded is price elastic. Wow, often we can say the demand, but it would be even more better if we're going to be even more precise to say the quantity demanded is price elastic. Just that the quantity demanded is price elastic, or you could say the demand is price elastic. Okay, but a product cannot be elastic or inelastic. So I went a bit fast on this simply because I have already explained that in the introduction. Yeah, so that's why this allows us to move a bit faster. This is all about how strong the relationship is. We know that there is a negative relationship. Okay, so the higher price will lead to a decrease in the quantity demanded unless we have a perfectly price inelastic demand. But then how strong the relationship is, we have like several possible cases. Then what you can do is to say, all right, how about, can we use diagrams to show the different cases? The answer is a bit complicated actually when you think about it. I'm going to explain, but to keep it simple, yes, it is true that if you draw a demand curve that is relatively flat, then it's likely to be elastic, price elastic. If you graph it relatively steep, it's likely to be price inelastic. If you graph it horizontally, then it is perfectly price elastic at some price. So it's always at some price, okay? It doesn't mean it's not perfectly price elastic at any price. There is one price at which it is perfectly price elastic. And if it is vertical, it is perfectly price inelastic. Okay, but we have to be careful because it's not as simple. You can actually have a demand curve that is very, very steep. But if you take 2 prices, you can actually calculate or conclude that the demand is price elastic. Let me just show you what I mean. I'm going to share the whiteboard. It's going to be easier. Okay, do you guys see the whiteboard? You should see the whiteboard. Okay, let's say, okay, that's going to be a very ugly. I apologize. Oh, I like graphing on PowerPoint, but I don't really know how to do that properly here. Okay, so of course, this is the quantity demanded. Can I actually do this? No, I cannot. And this is the price. Okay, so far so good. Now, what if I draw this demand curve? Can I move this? Okay. What if I draw a demand curve like this? Is this elastic or is this inelastic? Well, if you show that to your students, many of you will tell you, wow, that's a pretty steep demand curve, right? It's a pretty steep demand curve. But actually, if I take these 2 prices, if I can grab them, if I take like one price here and one price here, okay, like P1 and P2, let's say I decrease the price. P1 and P2. And of course, the corresponding quantities, okay, I'm not going to graph it, but imagine, okay, the corresponding quantities. You would actually find that the demand is price elastic. And same thing, if I take this demand curve, like something like that, it almost looks like comparative advantages, right? And if I take two prices very close to zero, for example, one here and I say one here. And if I calculate the elasticity, I would actually find that it's price inelastic. Because you know that a demand curve that is a straight line, it doesn't matter what the slope is, always has a price elastic section and the price inelastic section. It is always price elastic above its midpoint. So the midpoint is going to be, I don't know, somewhere here for this one. And always price inelastic below its midpoint. So if I have like the two midpoints of these two curves, it essentially means that above this green dot, the demand is actually elastic. And this means that below this green dot, the demand is actually inelastic. So that's quite confusing, right? That's why we have to be careful with just simplifying things. It's true that if you just do that, okay, if you just represent one section, not all of it, just one part of the demand curve, then okay, that works. If you do this and this, yes, because you only represent a section. So in that case, it actually works. But if you graph like the demand curve, it's entirely, then you really have to be careful, because remember that any demand curve that is a straight line, doesn't matter what the slope is price elastic above the midpoint and price inelastic below its midpoint. So you should really be careful with that. Okay. And this is not really something that I have seen in many books, but I think it's worth it to explain it. All right, but okay, to simplify, yes, if you have something pretty flat, if you just represent one section of it, that's going to be price elastic. And if you have something pretty steep, again, I only represent one section of the demand curve, then it's going to be price inelastic. Okay, and then I like this diagram. I think it's pretty interesting. What I've done here is I have graphed two demand curves, one that is relatively steep, the other that is relatively flat, and they intersect at point A when the price is 8 and the quantity is 10. Okay. And then as I say, okay, the price rises from 8 to 10. What happens to the quantity demanded of each good, say good 1 and good 2? And yes, we see that the demand for good 1 is much flatter, and therefore the quantity demanded will decrease a lot from 10 to 4. But the demand for good 2 is relatively steeper. So for the same increase in price, same percentage increase in price, the percentage decrease in quantity demanded is much lower. Okay, so the percentage increase in price is 25%, correct? Plus 25% from 8 to 10. And the percentage decrease in quantity demanded, if we look at D1, that's going to be minus 60%. So we should have an elasticity equal to 2.4. Am I correct? I don't know. And the PD along D2 should be 0.4. Yes, correct. So yeah, so it's very clear, and that's a good example on how you can but again, I call it a quick and dirty way. Yes, but it often works. Just have to be careful. How simply looking at the slope of demand curve or comparing the slope of two demand curves, how you can determine whether the demand is likely to be price elastic or price inelastic. And this is a first exercise for your students to calculate the PD. So make sure they do it. Make sure they do the exercise. And again, I strongly encourage you to tell them First, calculate the percentage change in price, then the percentage change in quantity demanded. Once you have that, you calculate the ratio. Don't try to do everything at once. You are likely to make a mistake. Okay. How about a perfectly priced inelastic demand? How does it look like? Well, it's vertical, of course. It doesn't matter how much I change the price, the quantity demanded remains exactly the same. So here I raise the price, the quantity demanded is the same. And here I cut the price and the quantity demanded again remains exactly the same. Okay, no problem with perfectly price elastic demand. Now, how I really don't like the representations that we find in books of perfectly price elastic demand, because usually what you have is this, right? But to me, this has never really made sense, because clearly, and I should actually add it. Let me just add a little something. Let's just add one price there. Okay, a certain price. Just a sec. Yes. So yes, here we have the demand that is horizontal at P1. But then what happens below P1? What is the demand below P1, right? There is no curve, right? So does it mean that there is just the demand doesn't exist, that the demand is not defined? And same thing, what happens when the price is actually higher than P1? How much do people want to buy? Is it possible? So that's why I really don't like this representation, because it seems like there is only one price possible. And that at that price, the quantity is anywhere between 0 and infinity. I just find this unclear, very unclear. So, but for the kids, it's enough, right? If they do that in the exam, if they graph this horizontal line and if they say it's perfectly elastic, okay. But it just, it's not very clear. So I like, I have added the one step further star, but I like this representation much better. The idea when you have a perfectly price elastic demand, what it means is that you have a certain price, P1. Above it, nobody wants to buy. So the quantity demanded is 0. So the demand is actually given by the vertical axis, okay? Above P1, there is 0 demand for the product. And below P1, there is an infinite demand, like everybody. Oh, okay, it doesn't have to be infinite. In theory, it should be infinite, but it's very large, essentially. Okay, there is a very large demand. Why don't we represent it? Because you can't really represent something that is infinite. Yeah, so I should not even do that. I should not even represent something that is infinite, and that's why there is like some dots to say that I have broken the axis. But essentially, that means that the demand is somewhere very far, okay? Very big, very, very big demand for any price below P1. And to me, that makes more sense, don't you think? 0 demand above P1 and very, very, very large demand just below P1. And actually, we would not even need this horizontal line, okay? We could get rid of it. Just say, well, P1, it doesn't really matter, it's just one price. But usually we add this horizontal line just to connect this to the vertical section. Okay, that's about it. But what really matters, above P1, 0 demand, below P1, infinite demand. Okay, we just add the horizontal section to connect these two sections. Okay, so what if, let's say, the price is P1, and so we could be anywhere, okay? Let's just say we are there at Q1. What if we increase the price a little bit? So plus epsilon means I just add the like 1 cent, the smallest possible unit of money. Then you see that, boom, the demand would just become 0. So that's like an infinite decrease, or a 100% decrease in the quantity demanded. So very small increase in price, very big decrease in quantity demanded. And on the other hand, if I decrease the price just slightly, minus epsilon, so minus 1 cent, then the quantity demanded would move from Q1 to a very, very large, maybe infinite quantity. So yeah, I like this representation better. I think it's easier to understand it than simply this, right? It's a bit weird, I feel. It's up to you. You decide. If you want to keep it simple, you can just say, right, that's horizontal, boom. If you want to try to go a bit beyond, you can attempt to introduce this representation, this alternative representation to your students. Makes more sense to me, at least. All right. Then there are some extra slides that I will skip today, and I do not print them for the students. If you want to get them to calculate more elasticities, it's fine. I like this one though. This one is fun because you see that you have 3 demand curves. They have the same slope. They have exactly the same slope. We have the exact same decrease in price. Okay, in 3 cases, we decrease the price from 8 to 6. And therefore, you see that, so we move from A to B, from C to D, and from E to F. And in all cases, you see that the quantity demanded increases by 1 unit. So if you ask the students, so can we conclude that if I calculate the 3 PEDs on D1, D2, and D3, should we find the same value? Actually, most of them will say yes. It's very tempting. Same slope, same decrease in price. We just lose $2, and the quantity demanded increases by 1 every time. But then you can just say, okay, do it. And then you find this. You find that no, you have 3 different values. The demand is actually, the demand on D1 is price elastic. The demand D2 is unit price elastic, and the demand D3 is actually price inelastic. It's pretty fun, right? Because you have to think of the PED in terms of percentage change. So yes, from 8 to 6, it's the same percentage change, but from 2 to 3, 5 to 4 to 5, and 6 to 7, that's not the same percentage change. That's why. Okay, this I skip all of it. Arc versus point elasticity, that's too advanced. Okay, so the difference between the different methods you can calculate an elasticity, either between 2 points or at 1 point. Let's just skip that. It's very interesting, but it's far beyond the syllabus. Okay. And then you can start introducing a very important idea according to which the PED is not constant if you have a demand that is represented by a straight line. And in most cases, we look at demand curves that are represented by a straight line, so the slope is constant. And some students feel like, hey, the slope is constant, so that means that the PED should be the same. It doesn't matter if I move from X to Y, from Y to Z, from Z to T, I should find the same value because the slope is the same. But again, the answer is unfortunately no, because even if the slope is the same, the percentage changes in price and quantity demanded are not. So again, just you can challenge them, and that's again another occasion for them to calculate PEDs. So then that should become easy for them. Do the same thing, and you see that from X to Y, the demand is very elastic. From Y to Z, it is unit price elastic, and from Z to T, it is price inelastic. So of course, I have chosen values so that we have the 3 cases all the time. So yeah, quite interesting. And then you can give them the general diagram, and this is what I explained early. If you take a demand curve that is a straight line, the upper section above the midpoint, M is the midpoint, is price elastic. The lower section down the midpoint is price inelastic. The vertical intercept is perfectly price elastic. The horizontal intercept perfectly price inelastic. And at the midpoint, the demand is a unit price elastic. Well, that's just about why is this the case? Because it's all about percentage changes. If you start from V, for example, the quantity demanded is 0, right? So if you increase the quantity demanded from 0 to 0.1, that's an infinite change, okay? Because you start from 0. So from 0 to 0.1, that's an infinite change in quantity demanded. So that's why the demand is perfectly price elastic. But then if you look at, for example, point H, so here, when the price, let's say that you decrease the price from 0.1 to 0, well, again, that is not what is the best way to explain it? Just a sec. Perfectly price inelastic, because you decrease, yes, you decrease the price. When you decrease the price from 0.1 to 0, or even from 0.00001 to 0, it is a 100% decrease in price. So that's a huge percentage decrease in price. And as a result, the quantity demanded will increase just by a little. So that's why the demand becomes perfectly price inelastic. If you want to explain it, if you don't want to explain it, it's also fine. But yeah, what they got to remember is the first sentence. When the demand is a straight line, when it's linear, then the PD in absolute value decreases as we move down along it, from plus infinity, perfectly price elastic, to 0. It doesn't matter how flat or steep the demand curve is, that's always true. Okay, and that's what I explained there. Okay, very, very important. Then I have one exercise. For them to calculate a PD to determine whether the demand is price elastic or price inelastic. That should not be a big problem. You see in my answer, I actually do step by step. First, I calculate the percentage change in price, then the percentage change in quantity demanded, and I add the signs. So even when it's positive, I add the plus sign just to emphasize that, yes, it's an increase. Okay, it's an increase in price. So I think it's a good practice to especially make sure we don't forget signs, like positive or negative signs. I think this matters. Okay, simple exercise again to calculate one last elasticity. This is an additional question to use the midpoint method, but you should not teach the midpoint method to your A-level students. And one more, because again, practice makes perfect, right? So this is something that I have added. Very easy, just to calculate 4 additional PEDs. So the price, the initial price is 10 always. The initial quantity demanded is 100 always. The new price is 12 always. So the only thing that changes is the new quantity demanded. And well, you should find the 4 cases: perfectly price inelastic, inelastic, unit elastic, and elastic. Okay, so again, that's another way to practice that. Okay, do you guys have any questions at that stage? Are we good? Okay, I'm just gonna go get some water because I am out of water, and I'll be back in a second. So we can take 2 minutes, 2-minute break, and I'll be back right away. Okay, that's better. Right, no questions at that stage. So let's discuss something quite important, the relationship between the PD and the total revenue of a business. So yeah, start by defining what is the total revenue. You can simply give the formula. That should be pretty straightforward. And then start, well, my teaching style is mostly based on like questions. I think we call that inquiry-based learning. That's what I do. So I usually try to challenge them and say, all right, what do you think? What do you think is going to happen? To get the class to discuss, to debate, and then once we have different opinions, when we have discussed the question, then I try to go through the content and summarize the key points. So you can just ask him, all right, if you increase the price, if you're a business and if you increase the price, are you going to get more money at the end of the day? And usually students, they guess that, hey, maybe not, because yes, of course, that means two things. That means that every unit that you sell will generate more revenue, of course. That's what I call the good news, to simplify. But on the other hand, because you raise the price, you are likely to have less buyers, fewer buyers. That's the bad news. And overall, it's quite intuitive to understand that whether or not your total revenue will increase or decrease depends on which effect is the strongest. And to keep it very simply, if you increase the price and as a result, the quantity demanded decreases just a little, then total revenue will rise. But if you increase the price and you lose many customers, then at the end of the day, total revenue will fall. So I don't know if you guys used my PPT from last year, but I have modified this section because I feel like the way I am introducing it now works better. Last year, there was something about the price effect and the quantity effect, but this was a bit confusing. Okay, and now how do we relate this to the PD? If the demand is price inelastic, then if you increase the price by, let's say, 20%, then the quantity demanded will only decrease by, say, 10%. So overall, TR will, total revenue will rise. And that's what I do. That's usually what I did on the whiteboard with my students, and I decided to add it to the PPT because it usually makes sense to them. Okay, so you increase the price by this amount. Okay, so the size of the arrow measures, let's say, the percentage increase in price. Okay, and you see that the quantity demanded decreases, but just a little. So overall, the total revenue, which is just the product, will increase. Okay, not by as much as the percent change in price, but it will increase. Usually that makes sense to a student. However, if demand is price elastic and you increase the price, okay, you increase the price by this amount, say, then the quantity demanded will decrease a lot in percentage, okay, will decrease a lot. So overall, the product will be lower, the product will decrease, so total revenue will decrease. And finally, if the demand is unit elastic, if you increase the price by 20%, the quantity demanded will all decrease by exactly 20%. So that's why the arrows have the same height, but the opposite directions, of course. And as a result, your total revenue is constant. It will not going to change. What do you think? You think it's a better way to explain it than last year? The way I had it on the PPT last year? I think it's easy. It's intuitive to explain it this way. Okay, and then I do the same thing with a decrease in price. Okay, but I'm not going to repeat it because it is exactly the same. So you can do the first with your students, and then you can just ask them to tell you in advance. You tell them, don't look at the PPT. You tell me now what happens. What is the good news? What is the bad news? What if demand is price elastic? You ask them to draw this diagram or this relationship. What if demand is price elastic? What if it's unit price elastic? You consider all the cases, and they should be able to understand how this works. There is another way you can approach it. You can graph it. And so, for example, let's say that we start from point A, So the total revenue is 16, okay, price times quantity. And you decrease the price from 8 to 6. So you move down along the demand curve from A to B. So you have a new total revenue, okay, 18. So essentially, initially we had 16. Now we have 18. So total revenue has increased by $2. All right, but we can try to understand what happened. The good news is this one. That's the gain in total revenue. Now, the price is lower, so you sell one more unit. You used to sell 2, now you sell 3. So you gain $6 plus 1 unit times the price, $6. All right. But the bad news is that now every unit that you sell it at a lower price. So you used to sell the 2 first units at $8, and now you only sell them at $6. So you lose $2 per on the first unit, and you lose $2 on the second unit. So overall, you lose $4. So you lose $4, you gain $6 overall. Your total revenue increases by $2. Okay, that's an increase. You can do another case. For example, this one. So same thing, 8.3. So total revenue 24. You decrease the price. Quantity demanded rises. So your total revenue is again 24 in this case, right? So this case is interesting. The total revenue has not changed in this case, right? What happens? So again, this is the bad news. You lose $2 on the first, second, and third unit of output. Okay, you used to sell them at $8. Now you only sell them at $6. But on the other hand, you are very lucky because, well, you're not lucky, but the price is lower, so you can sell a fourth unit. So you gain $6. And you see here that what you lose is exactly equal to what you gain. And therefore, that's why your total revenue remains unchanged. And you can do a last case if you want. This is a case where the decrease in price actually leads to a decrease in total revenue. You see, you had 48, now we have 42, which essentially means that what we lost is greater than what we gain. What we lose here is $2, but on 6 units, first, second, third, fourth, fifth, and sixth unit, on each of them we lose $2, and we only gain one additional unit, one additional sale at $6. So we only gain $6. So we lose 12, we gain 6. So at the end of the day, we lose $6. I have already also done the diagrams in the case of an increase in price, but of course it's not necessary to do everything, but you have the case of an increase in price, and same thing. What is the good news? What is the bad news? What have we gained? What have we lost? Blah, blah, blah. So you can do that. However, if you use these diagrams, you should not calculate the elasticities because you might have some problems. For example, if you calculate the elasticity in that case here, I don't think you will find the PD is equal to -1. I have not done it, but from 8 to 6, that's 25% decrease. And from 3 to 4, this is not 25%. So you see that you would not actually find that the PD is equal to 1, even though the total revenue doesn't change. This is because what I said earlier, if the demand is a unit price elastic, it's only for very small changes in prices. Okay, it's only when we calculate what we call a point elasticity, not when you calculate the elasticity between two distinct points on the demand curve. So that's why that would not work if you calculate the PD. Even though the total revenue doesn't change, you would not find a PD equal to 1 in this case. So just, I like these diagrams because they clearly illustrate the benefit of cutting the price and the cost of cutting the price, but do not calculate the PD. That's gonna put you in trouble. Don't do it. Because again, you see here we would calculate an arc elasticity from A to B, not a point elasticity, so that's not gonna work. Okay, so we have all the possible cases. Yes, it took time, so we can skip all that. All right, and at the end of the day, this is a very important diagram. This is really what you have to, that's the conclusion of this relationship between PED and total revenue. Of course, if the quantity is 0, then total revenue is 0. So you start from 0. And if the price is 0, right there, of course, total revenue is also 0. So you have like 2 points. Then we know that on the upper section of the demand curve, the demand is price elastic. So if we start from this point, if we start from the vertical intercept, and we move down along the demand curve, okay, so we increase quantity and we decrease the price because the demand is price elastic. If I decrease the price, total revenue will start to increase, okay, so I will be on the upward sloping section of the total revenue curve. But then if I keep decreasing, if I keep going down along my demand curve, I will eventually reach the midpoint where my demand becomes unit price elastic, PED is equal to 1. And if I keep cutting the price, then I now stand on the price inelastic section of the demand. So in that case, if we keep decreasing the price because the demand has become price inelastic, then total revenue starts to fall. So what does it mean? It means that my total revenue is maximized when the demand is unit price elastic. Okay, that's a very important diagram. And they should be able to explain it clearly, to explain what happens, to connect these two curves, or this demand curve and the total revenue curve. There is one special case that they should know, is when the demand is isoelastic. I think we pronounced this iso, but I'm not quite sure. Isoelastic. ISO, not sure. Which is simply a demand whose PED is constant and equal to 1. Because remember what I said? I said that if the demand is a straight line, then the PED actually changes, okay, as we move down along. An isoelastic demand has a constant PED equal to 1. So it doesn't matter where you are, the PED is always equal to 1. It's not a straight line. If you graph it, it's actually convex. We call that a rectangular hyperbola in math. I've actually included this term because it has been used before in MCQs. So if your students, they see something like a rectangular hyperbola, they should understand that this is an isoelastic demand with a constant PED equal to 1. And in this case, what is interesting is that the total revenue is constant, okay? Because if the PED is always equal to 1, you cut the price by 1%, quantity demanded increases by 1%, so the total revenue remains the same, and you can do that as much as you want, the total revenue will remain exactly the same. The typical example, let me show you, would be something as stupid as P is equal to 1 over QD, okay? That's your demand, right? The price and that the quantity demanded, and that's the relationship. So in that case, if you want to calculate your total revenue, that would be the price times the quantity, okay? Something like that. The price is 1 over QD, okay? And you multiply by QD, okay? So that's just 1 over QD times QD, so it's just equal to 1. So you see that in that case, if this is your demand curve, 1 over QD, well, your total revenue is always equal to 1. It doesn't matter where you are, always equal to 1. That's one example of a rectangular hyperbola. All right, so that's how you can graph it. You see A, B, C, D, I have this demand curve. It is not a straight line. And at point A, at point B, at point C, at point D, the demand is always, or the total revenue, sorry, is always equal to $10. Again, do not calculate elasticities, please. If you calculate an elasticity from A to B, from B to C, from C to D, you will not find that it is equal to 1. Here it's, for example, minus 50%, but here it is 100%, simply because, again, this, when I say that the PD is equal to 1, I mean the point elasticity of demand. So the elasticity at every given point of the demand curve, not between two distinct points. Okay. So do not calculate the elasticity and do not panic if you see that, hey, why it doesn't work? No, because it only applies to point elasticities. Okay. Last thing that we have to do, and this is going to conclude the PD, and then we'll be able to quickly do the YED and XED because it is much quicker. There will be a few more things to say about the PES, but the YED, XED is very quick. The determinants of the PED. Okay, so essentially, your students should be able to state determinants, to explain them, and to illustrate them. Okay, it's very important. Statement, explanation, illustration. The first, what do we mean by a determinant of the PD? It's something that has an influence on it. Okay, something that influences the value, not the sign, because we know that the PD is negative, but that will make the demand more or less elastic, essentially. So there are a few factors that can affect the value of the PD. One is, of course, the availability of substitutes. The more substitutes you have as a consumer, the more price elastic the demand. So that's the statement. The explanation would be because if there are many substitutes, it's easy for you to switch from one product to the other. So if one product becomes more expensive, you will just stop buying it and instead you will buy other varieties, other brands, for example. Which goods do you think have many substitutes? Okay, this is a nice class discussion that you may have with your students. Okay, which products have few substitutes? And then you can discuss, okay, so can we expect that the demand is elastic, inelastic? That's a good class conversation you can have with them. A remark, because again, of course, how many substitutes a product has depends on how broad you define it. So if I ask you, what is a substitute for eggplant? That's going to be easy, right? You can tell me, okay, zucchinis, pepper, okay, things like that. But if I ask you, okay, what is a substitute for food? You see, food is very broad. It includes many things, and you can't really think of any substitute for food. If I tell you what is a substitute for BMW, quite easy. You can tell me, okay, Mercedes, something like that. But if I tell you what is a substitute for a car, you have less choice. Yeah, you could say a train or something like that. But the number of substitutes depend on how broad you define the product. Time is, of course, relevant, simply because the more time you give to consumers, the more time they have to adapt their behavior. If you just give them 20 seconds when you increase the price, or even just one day, there's not much to change their consumption patterns, because we all have patterns and we cannot, and it takes time to change our habits, or simply to realize that the price has changed. Sometimes we don't have perfect information. We need time to realize that something has changed. Okay, so if you give more time to the consumers, then they will have the ability to adapt their consumption patterns and to modify, to change the quantity demanded of a product whose price has changed. They can do that in the long run, but they might not have sufficient time to do this in the short run. So that's why the more time you give to them, the more elastic the demand for a product, the more sensitive consumers become to changes in prices. The example that I gave is about the demand for oil, or even the demand for gasoline. Let's say that the price of gasoline increases, and let's take an extreme example. Let's say that fuel, or whatever fuel you put in your car, let's say that the price is multiplied by 4. Just in one day, you wake up and fuel is 4 times more expensive. In the very short run, if you only look at, let's say, 1 week, something like that, well, you still need to go to work, right? You still need to drive your kids to school. So you will be stuck. You will still have to buy pretty much the same quantity of oil or gasoline. So the demand is going to be very inelastic. But if you consider, say, 1 or 2 years, you might actually take actions to reduce your consumption of gasoline. So you might purchase an electric car. Instead, you might relocate closer to your work or your kids' school. You could do some carpooling, so go to work with someone else. But it takes time, right? It takes time to change your habits and to respond to this price shock. So that's why time is something that matters, that has an influence on the PED. Necessities versus luxuries, you know the idea. Yes, the demand for necessities, they tend to be less elastic than that of luxuries, simply because, well, we still, even if necessities are expensive, we still need them. We still need food, we still need housing. There are some products that we don't really have the choice. We have to purchase at least a certain quantity. So we might reduce a bit our consumption of necessities if the price rises, but it's complicated. It's complicated because they contribute greatly to our satisfaction. So every unit of a necessity that we give up, that we sacrifice, costs a lot in terms of our satisfaction. On the other hand, it's easier to sacrifice luxuries if they become more expensive because they are non-essential. Okay, remember that a necessity is not necessarily something of a bad quality, and a luxury is not necessarily something of good quality. Necessity is something essential, luxury is something non-essential. So the price rises, okay, we can simply, it's easier to give it up, basically. Also, in an I'm reading the chat box. Also, in an emergency, very urgent, short-term, consumers would be willing to pay a high price. Yeah, so the demand will be very inelastic. Yes, if there is an emergency, of course, if you are about to die, I think you would be willing to pay any price to be saved by anyone, right? But if you knew that you had like some time to, if you had a few weeks or a few months ahead of you, then you might actually not be willing to pay any price, or you would find, or at least you would find maybe ways around it. But if there is an emergency, you might not have enough time to analyze the situation and make the best possible decision. This could be an information failure. And in that case, yes, it's possible that your demand is going to be very, very inelastic. Absolutely. Yes. So I took examples of comparing necessities and luxuries. So DVDs, we can regard this as a luxury. It's just non-essential. Insulin is a necessity for those suffering from diabetes. Food, clearly a necessity. Cinema is non-essential. It's a luxury. Careful, because again, many students give the example of expensive things when they think of luxury. So they will tell you, yes, Louis Vuitton bags or jewelry or expensive cars. No, I don't like these examples. They should really think of luxuries as something non-essential. A cinema ticket is a luxury. It's non-essential. You can live without it, no problem. That makes it a luxury. Housing is a necessity. On the other hand, travel is not a necessity. Traveling is a luxury, not because it is expensive, but simply because it's quite easy to live without it. You can have a perfectly normal life without going to Tahiti every summer. The budget percentage is essentially what is the percentage of your income, or what is the percentage of your income that you allocate to one particular product. And the idea here is that if you allocate a high percentage of your income to one product, then you will be very sensitive to price changes. So the demand is going to be relatively price elastic. But if you allocate only a very small percentage of your income to that product, then the demand is going to be very inelastic. Why? Simply because if something doesn't represent a big share of your income, to put it simply, you don't really care if the price changes. The example that I use is the price of public bikes. Like when I first moved to China, it was 4 years ago, I was in Xi'an, and I used Mobike. I don't know if there are many cities that still use mobiles, but that's what I use. And at first, it cost 1 RMB for 1 hour, I think. And then suddenly, the price was increased from 1 RMB to 1.5 RMB. That's actually a 50% increase. That's huge, right? 50% increase in price, suddenly. And then I asked my students, all right, what do you think I did? Do you think I say, oh, wow, now I can't afford it. I can't really ride the public bikes. Like there was a 50% increase in price. And then they tell you, no, you didn't change your behavior. You didn't use the bikes less because, okay, there is a big increase in price, but that still represents a very small part of your income. And yes, we don't really care when the price of something very, very cheap, or at least something on which we don't spend a lot, increases. Okay. So on the other hand, if you spend 50% of your income on, I don't know, 40% on, let me try to find an example on going out to the restaurants, for example. So let's say you go to the same restaurant every month because you like it. Every weekend you go to the same restaurant and it's expensive. So you spend 40% is maybe too much, 25% of your income on that restaurant. That's still a lot, yeah. Well, if the restaurants increases all the prices of the food and drinks and all, well, now you might actually care, right? Because that might actually be a big deal. So if they increase everything by 50%, it's more likely that you will reduce, that you will say, okay, maybe I should only go once every 2 or 3 weeks, yeah? So we are more sensitive to price changes if they are associated with bigger budget percentages. Okay, of course, you have the case of habit-forming products. What does it mean to be habit-forming? I gave the definition. It is something that is capable of leading to a psychological or physical or physiological dependence. Basically, something that can make you addicted. So, of course, we think of drugs, we think of cigarettes, we think of alcohol and heavier drugs, but it could be video games, could be social networks, could be coffee, anything that can create. Do not underestimate the importance of psychological addictions as well. Or it could be work, and some people are workaholic. So that's another form of addiction. Brand loyalty, I think that's the last one. Yes, brand loyalty is also something that makes the demand, and of course, sorry, I didn't really explain how this works for habits-forming products. When a product, when consumers have a certain level of addiction to a product, of course, the demand for it is likely to be less elastic, because even if the price increases, they are likely to buy pretty much the same quantity simply because there is a form of addiction to the product, and they will accept to pay a higher price and spend more simply to maintain their level of consumption. Brand loyalty is actually pretty much the same as if you decrease the number of substitutes. Because if a business is successful at creating brand loyalty, it's like if the consumers don't even look at the substitutes. So it's like if you blind them, okay? It's like if they don't see the substitutes anymore. And the example that I use with my students is to ask them, okay, how many of you have an iPhone? Usually you have at least 50% of students who have an iPhone. And then I say, all right, unfortunately, your iPhone doesn't work anymore. So you need to get a new phone. All right. In that case, do you think you would consider buying any brand of phone? Could be Samsung, could be Apple, could be Huawei, Xiaomi, Oppo, Honor, could be anything. Or would you go straight away to the Apple store? And most of them, they will tell you, no, I'll just go straight away to the Apple store. And there are several reasons for it. Maybe they are used to using the cell phone, it's just more convenient. But of course, there is also a certain form of brand loyalty that just leads to a situation where consumers, they don't even consider that, oh yeah, there are other brands. I could also purchase the product from other businesses. So it's equivalent to reducing the amount of substitute that consumers consider acceptable. And in that case, the demand is less price elastic. Yes. So if we assume that there is a stronger brand loyalty for Apple smartphones than for Honor smartphones, I think it's fair to say that, then we can expect the demand for Honor phones to be more elastic than that of Apple phones. Okay, and we are done with the price elasticity of demand. So that was the big part, because this was the first one, and this is by far the biggest part of this PPT. Any questions before we quickly look at the income elasticity of demand and the cross price elasticity of demand? Any questions? So yeah, we've already done more than 2/3 of the slides, and the rest is going to go really quickly because it's essentially just repeating what I've already said. So I should be rather quick. No questions? Okay. So income elasticity of demand is the same, but instead of changing the price, we change the buyer's income. Okay, so it's exactly the same formula. W is for income. In microeconomics, that's usually what we use. If you want to use Y, because it's a YED, we can replace it, but I like to use W. Unlike the PD, it can be positive or negative. Okay, in the PD, it was only negative because we had the law of demand. But here, if you the impact of a change in income on the demand, it depends on the type of good you are dealing with. Depends on if it's a normal good or an inferior good. I remind, I give the students, they know that already. What is a normal good? Essentially a good such that there is a positive relationship between income and quantity demanded. And because there is a positive relationship, the YED is going to be positive. An inferior good is the opposite. There is a negative relationship between income and quantity demanded. And therefore, the YED is negative. Then you can just, as a summary, or just to review some, because it's always important for students to be able to give examples. Let's try to, you can ask them, okay, give me a few examples of normal goods, give me a few examples of inferior goods. Remember that my two favorite examples of inferior goods are bus tickets and public transportation in general, and potatoes. These are my two favorite examples that I use. Okay, then the diagrams, I just copied them from the PPT on demand. So the students have already seen that, so we can skip all this. We can also skip that, the angle curves, which is, it's outside the scope of the syllabus. It's essentially a curve that shows the relationship between income and the quantity demanded, okay? So if it goes up, you have a normal good. If it goes down, you have an inferior good. Okay, that's interesting, but the students are not expected to know that. So I do not print it, and I usually do not talk about this to my students. Then same thing, you have the value, because we discussed the sign can be positive, can be negative, normal good, inferior good. But then we can say, all right, is this going to be greater than 1 in absolute value? Is this going to be less than 1? If it's greater than 1, it's income elastic. And that's why it's important to mention whether you are talking about something being price elastic or income elastic. And if it is less than 1 in absolute value, then we say that it is income inelastic. And then it's important to define these two keywords, what we call a necessity and a luxury. We've mentioned that before when talking about the determinants of the PED, but we had not define precisely what we meant by necessity and luxury, but it's quite simple. A necessity is a normal good, okay, because the YED must be positive, but that is income inelastic. So the YED is positive normal good, but inelastic, income inelastic, less than 1. Basically, if your income increases by 20%, you will buy more necessities, but you will only increase your quantity demanded by, let's say, 10%. That's not going to be more than 20%. And on the other hand, a luxury is also a normal good, but it is an income elastic normal good. So the YED is greater than 0, normal good, but it is actually greater than 1 because it is income elastic. So for example, if your income increases by 20%, then the quantity demanded will increase by more than 20%. All right, same thing, you can ask the students, what do you, give me 2 examples or 3 examples of luxuries, something non-essential. Give me 3 examples of necessities, something that is essential. And then this is a small, short diagram that summarizes the sign and the value of the YED. Okay, inferior and normal, we look at the sign. Necessity, luxury, we look at the value. Then there is one additional slide about the relationship between the type of good that we consider and whether the budget percentage increases or decreases. But again, that's outside the scope of the syllabus, so it's okay to skip this. And then sometimes in the essay question, there are actually almost every year, there is one essay question about the elasticities. That's why it is such an important topic. And I'm actually quite happy with my PPT. Sometimes I'm not very happy, but I think this one is very comprehensive. And the reason for which I made it very comprehensive is because this topic is so important for AS economics. So I really wanted my students to be bulletproof on this. And in some essay questions, they ask you, all right, what is the YED and why is this important, or something like which one is the most important? Is this more important for a business to know the PD or the YED? So I have added this slide where I essentially explain why it's important for business to know the value of the income elasticity of demand for some products. And for businesses, it's actually more like expectations about whether national income will increase or decrease. So it's a bit halfway through microeconomics and macroeconomics. But the idea, of course, is that if as a business, if you expect that the economy will grow, if you expect, yes, economic growth, you expect that people will have more income. And as people have more income, they will buy more normal goods. So the demand for normal goods is going to increase, which should lead to a higher price, okay, of normal goods, which essentially means normal goods are likely to become more profitable. Okay, there will be a higher demand. There will be more people or willing to purchase normal goods, or each of them is going to buy more normal goods. So if you are smart and if you want to make profit, it makes sense to produce more normal goods and perhaps less inferior goods whose demand is going to decrease, because if people have more income, they will purchase less inferior goods. So this is why this is relevant for business. But on the other hand, if a business or if businesses believe that the economy is not going to do very well in the future, then if we have an economic recession, a lot of people will lose their jobs, they will have less income, and therefore the demand for inferior good is going to increase. So in that case, yeah, if there is more people willing to purchase inferior goods, it might actually be profitable for me to reallocate my resources to produce more inferior goods rather than normal goods. Okay, so essentially knowledge of the YED can give insight about what types of goods the firm should produce, because of course it's more interesting for businesses to produce goods that are in high demand. That's the basic idea, right? So that's essentially the idea why the YED is very important for businesses. And finally, you have one exercise where you calculate the YED and you have to tell if it's a normal good, an inferior good, a necessity, or a luxury. Okay, pretty easy. I'm not gonna comment them, but you see again, I separate the stage. First, we calculate the percentage change in income, and then we calculate the percentage change in, should be quantity demanded actually, not demand, but quantity demanded. All right, good. What picture? I don't even remember what picture I had. Oh yeah, I had the bus. Yeah, that's why. That's why I had the bus, because yes, I usually give the example of bus tickets for inferior good. That's why. Then, and this, I really hate myself for in displaying this picture, because I am very hungry. But yes, these two goods are clearly complements. Yes, of course. And you know that the cross price elasticity of demand is about substitutes and complements. So that's the same thing. And that's why the introduction is useful, because now we can move quicker. But here we try to explain the quantity demanded of good X when we change the price of good Y. Okay, of course, the two goods need to have some relationship. If they are completely independent, then nothing is going to happen. But we will see that case. And if we look at the sign of the XED, it tells us, it gives us information about the relationship between the two goods. In particular, are we dealing with substitutes in consumption or complements in consumption? If it is a positive, it's quite straightforward to understand. It means if you increase the price of Y, the demand for X will increase. That means that you have substitute in consumption, okay? You increase the price of tea, people buy less tea. Instead, they buy more coffee. Increase in price of tea, increase in demand of coffee, positive XED. However, if you if the XED is negative, then you have complements. Tea, sugar, and coffee, you increase the price of coffee, so that's a plus. So people buy less coffee, and therefore they buy less sugar. So that's a minus. So positive divided by negative, actually negative divided by positive, that's negative. Okay, easy. So positive XCD is substitute, negative XCD complement. If the XCD is equal to 0, it means that there is no relationship between the goods. They are neither substitutes nor complements. Could be in my PPT on demand, I used leather and coffee, right? Can you find any relationship between leather and coffee? Not quite. Okay, so that's about the sign, positive or negative. But again, as always, we also have to look at the value. Is this close to 0, or is this very different, very positive or very negative? And here, the size or the value of the elasticity gives you information about how strong the relationship is. So for example, in the case of substitutes, are we dealing with two goods that are very similar, very close substitutes? Is it very easy to replace one by the other? And in this case, the XCD is going to be very large to acknowledge that, yes, there is a very close connection between the two. And the closer the XCD will be to 0, this means that, yes, all right, the two products are substitutes to some extent, but they are still very different. Okay, so let me try to use two examples. So for example, for Pepsi and Cola, they are very close substitutes. They are not identical, but they are very close substitutes. If you take, on the other hand, something like Pepsi and milk, they are substitutes to some extent, because if you're thirsty, you can drink one or the other. You can replace one by the other, but you see that they are more imperfect substitutes. So the XCD is likely to be closer to 0. And that's the same thing for complements. If you calculate the XCD and you see that it is very negative, -2, -3, -4, this means that essentially it's very important to have the products together. You can't really have one without having the other. So for example, if you have a remote but no batteries, that's a big problem. Yes. If you have a razor but no razor blades, that's also a big problem. So in that case, we say that the products are close complements, or almost perfect complements, but you really need to have them together. But there are products that are complements in the sense that it's actually better if you have them together, but it's still fine if you only have one. And that's an example. Okay, maybe it's better if you have your coffee. If you have your coffee with your muffin. If you only have your coffee without the muffin, okay, that's not the end of the world, is it? Or if you order fries and you don't have ketchup, it's better with ketchup or whatever you put with your fries. But same thing. It's not the end of the world. You can still enjoy your fries, maybe a bit less, but you will still enjoy your fries a bit. So yeah, it's important to acknowledge that. So for substitutes, I gave the example of apple juice and the orange juice, very close substitute, versus orange juice and wine, remote substitute. And for complements, razors and razor blades, yes, and fries and ketchup. Okay, so that's the same idea. Okay, and the case of two goods that are independent would be guitars and memory sticks. So if you change the price of memory sticks, you can't expect it to have any influence on the demand for guitars. The same thing, this is a summary. So positive XCD is substitute in consumption, negative XCD complements in consumption. The more positive it is, the closer the substitutes, the more negative it is, the closer the complement. And zero, this means that they are independent. Same thing, I copied these diagrams from the PPT on demand. So this is just a reminder, just to make sure that they get it of the two cases. And again, what does it mean when the elasticity, when the XCD is greater than 1? Elastic with respect to the price of the other good. If it's smaller than 1, inelastic with respect to the price of the other good. Okay, and then finally, I introduced the concept of cross-demand curves, but this is beyond the scope of the syllabus. That essentially something like that, where you have the quantity of good X, but instead of having the price of good X, you have the price of good Y. All right, that's a cross-demand curve. And looking at the slope, if it's increasing or decreasing, you can find out whether you are dealing with substitutes or complements. Why is this important? Same thing. There is always, like I say, questions about explain why it is important to for business to know the value of the XCD. So it's often useful, especially for businesses like supermarkets that will sell many products, because it's important to know which products go together. So for example, you can display them together in the store if they are complements. And same thing, which products are actually substitutes. So you can again put them together. So information about the XCD essentially gives you information about what people buy together, what they can, the goods that are interchangeable for consumers. And it therefore allows you to improve your marketing strategy. Could be the packages, where you can actually offer some bundles where you will have the razor and the razor blades together, yes, or potatoes and ketchup together. I don't know. You can optimize the supermarket shelves to make sure that it is as convenient as possible for the customers. So yeah, it allows you to improve your marketing strategy if you know what products are purchased together. And it also allows you to know, okay, for example, if Pepsi Cola knows that the XED between Pepsi Cola and Coca-Cola is very high, this essentially means that, wow, consumers, they believe that what I sell is almost the same as what Coca-Cola says. So if I increase the price, I'm going to lose many customers So maybe it's not a good idea because consumers, they feel like it's almost the same, they will go for the cheaper product, right? So it's actually a very bad idea to increase the price. However, cutting the price means that I might actually gain many, many customers if they feel like Pepsi and Coca-Cola is essentially the same. And if they go for the cheaper product, then if I reduce the price, I might actually steal a lot of customers from Coca-Cola. So again, it gives information to the businesses about what form of competition is the most desirable. Is it better to engage in price competition where we try to offer the product at the lowest possible price, or instead non-price competition? So for example, if Pepsi Cola and Coca-Cola are perceived as very close products by the consumers, and this is indicated by a very high XED, then both companies will have an incentive to engage in non-price competition to essentially differentiate their product more, to try to convince their consumers that, hey, my product is actually different, to create a form of brand loyalty that will decrease the intensity of competition between Pepsi Cola and Coca-Cola. You might print pictures of supermarkets items and get students to place them on shelves with reasoning as an activity. That's a great idea. Yeah, let's just say, or what you can do is you can give them pictures of different items, and then you can give them a table with the values of the XED between each pair of products. And then you can ask them, all right, so if you are the owner of the supermarket, you know that, okay, people could consider these products as a substitute, a close substitute, and so on, or these two as a complement. What can you do if you want to maximize your revenue, or if you want to make your supermarket as convenient as possible? Yeah. Sounds like a great activity. Good idea. Okay, and then a final exercise to calculate a cross-price elasticity of demand to find out if the products are substitutes or complements. Well, we have tennis balls and tennis rackets. So if you have a student who tells you they are substitutes, we have a big problem. Okay. Well, actually, I should have done it. I should have taken this example and pick figures so they are substitutes, just to see how they would react, if they would be surprised or if they would not even notice. Okay. PES, the last one. That's going to be rather quick because, again, it's essentially the same as the PED. The only thing that differs are the determinants, essentially. So I will tell you later why I have used this picture. Definition, same. Dependent variable, quantity supplied, independent variable, price. The change in price explains the change in quantity supplied. And again, why is this important, the PES here? Because it gives information about how easy and how fast it is for a business to adapt to market conditions, okay? The price rises. If the PES is very low, please do not say very inelastic. If the PES is very low, that means that it's pretty tough for me to adapt to market conditions. I might not be able to take advantage of the changes that have taken place. If the PES is very high, not elastic, then that means that I really have the potential to increase my output or to decrease my output accordingly. And that basically means that I'm flexible. Okay, a low PES means that maybe I'm not very flexible, and perhaps I should improve that. Perhaps I should invest in any technology or any production process, or adapt my production process to gain flexibility. That's why it's important for business. Okay, so because of the law of supply, there is a positive relationship between the two variables. So yes, the PES is always positive, no problem. Then, just like demand, you have exactly the same thing. I have just replaced demand by supply. Okay, so that's the same thing. So I'm going to skip all this, exactly the same. You have the summary, okay, so it's positive from 0 to plus infinity. From 0 to 1, price inelastic. 1 to plus infinity, price elastic. 0, perfectly price inelastic, 1, unit price elastic, infinity, perfectly price elastic. Same as demand. You have the graphical representations. That's a perfectly priced inelastic supply curve. Again, so when we increase the price, in this case, we increase the price, no change in quantity supplied. In that case, we decrease the price, no change in quantity supplied. This is the simplified representation of a perfectly priced elastic supply. But again, I don't like this representation. I like this one much better. Below P1, quantity supplied is 0. Nobody wants to sell below P1. And above P1, everybody wants to sell. Okay, infinite supply above P1. Okay, so if we start from P1, quantity supplied is Q1. I reduce the price a little bit by epsilon. Quantity supplied falls to 0. And if I increase the price a little bit, quantity supplied increases to infinity. That's the idea. Don't you think it makes more sense, like to have this type of representation? All right, now there is something that is a bit tricky, which is this diagram, you know, right? Because there are some MCQs sometimes about this, where they give you supply curves that are straight lines. And they ask you, okay, look at this supply curve. Is this elastic? Is this inelastic? Unit elastic? And when we increase output, will the PES increase, decrease, blah, blah, blah. And I really don't like this question, because there is no intuition behind it. It's just a mathematical property. So we can prove it, yes, but there is just no intuition behind it. So it's a bit empty to me. Basically, if you want to prove it to your kids, if they like math, this is how you can prove it, but you don't have to do it. Okay, usually I don't do it. If supply is a straight line, then the equation is something like that, okay? Just like y is equal to ax plus b. So here it's not y, it's p, it's not x, it's qs, but okay. And because the supply is upward sloping, the slope is positive. Okay. Now you can actually calculate the PES. So if you use that, and if you calculate the PES, and if you rearrange the terms, this is how you can express the value of the PES, okay? 1 plus b over aq. A is positive. That's the slope. Q is positive. It's a quantity. So the denominator is always positive. So at the end of the day, you see that the PES is 1 plus something. If B is positive, so B is the vertical intercept. So if the vertical intercept is positive, then the PES is greater than 1, price elastic. But if B is negative, negative vertical intercept, then the PES is 1 plus something negative, so it's less than 1. And finally, if B is equal to 0, so essentially the supply curve goes through the origin, then the PES is 1 plus 0, so it's just 1, a unit elastic. And you see that, yes, if B is positive, then the PES will decrease with the quantity, okay, because Q is on the denominator of something positive. But if B is negative, then the PES increases with Q, because Q is on the denominator, but you have a negative sign before your ratio. But so you see, that's just stupid, right? There is no nothing to understand. It's just you can show it, but there is nothing to understand in terms of economic intuition. So just show them. So you have the summary. You have the summary of what they must know, and just say, right, you see, look, it cuts the vertical axis above 0, it's elastic, and the PES is decreasing. Look, it cuts the vertical axis below 0, PES is inelastic, and the value of the elasticity increases, actually tends towards 1. Look, the supply curve cuts goes through the origin. You have a unit elastic supply curve, and actually the PES is constant. Usually, if you just get them to remember that, that should be enough. There is nothing to understand. Okay, finally, the determinants. So time just like for the PD, for the same reason, it gives more flexibility, more time to adapt. So the longer the time period, the more price elastic the supply. In the short run, farms might not be able to change their levels of production. It might be difficult to reallocate resources from producing one good to producing another. There might be some capacity problem where they don't have enough workers to produce more, not enough machines to produce more. And sometimes there are some products that simply take a long time to produce. Okay, so if I only give you 1 day, you're not going to produce 20 more buildings. That's a problem. So in the short run, you don't have time. In the long run, all of this can become flexible. You can reallocate your resources from one production process to another. You might buy more machines, hire more people, and you will have sufficient time to produce more. And that's actually why I added, let me just show you this. Boom. That's actually why I added that picture, because this is an example of a farm or a garden in which you produce many different things. Okay, I don't really see clearly what this is. But let's say that we have cauliflower and what do we have? And zucchinis, for example. If the price of zucchinis increases, you want to produce more, but you might need more space in your garden. You might have to stop producing cauliflower and instead produce zucchinis because it's more profitable, but it might take some time for you to do that. You might be unable to do this in a very short period of time. There are actually substitutes in production. They are in competitive supply in this case. So yeah, time is very relevant. What example did I give? If the price of running shoes increases, the producer that operates at full capacity may not be able to significantly increase the quantity that it supplies in a short or very short run. I can't produce more, even if I wish I could. In the longer run, however, it could build a new factory, hire additional employees in order to increase its production capacity. So of course, in that case, in the long run, I do produce more when the price rises, therefore higher PES. The ability to hold stocks. Here, the idea is that if you have stocks and the price rises, you can simply sell off your inventory. Okay, you already, let's say you have cars, the price of cars rises, immediately you can just sell what you have in stock, what you have in your inventory. So you don't need time to produce new cars. You can immediately supply additional cars in the market if it's more profitable. And therefore, that makes you very flexible. There are some things that can be easily stored. Cars, for example, even though cars are actually quite big, it's better to find examples of things that are very small. So it's cheaper to store. So if you think of, I don't know, staples are not very expensive to store, or even paper. Yeah, stationery or pens or things like that. They do not deteriorate over time. They are not very sensitive to humidity or to room temp or to a high or low temperature. So it's rather cheap to store stationery. So if there is an increase in the price of paper, immediately you can just sell some of your inventory. That makes you very flexible. On the other hand, there are some things that are very difficult to store, especially in the long run. Things that are perishable, like fresh meat or fresh vegetables. Of course, you could freeze all that, but they are no longer fresh then. And the best thing, what I like, the example that I like in terms of storage is electricity. Electricity is very hard to store. So yes, of course, we have a battery. And what is a battery? It's just something that stores electricity. Yes, but it's very complicated to store large quantities of electricity. And the example that I like to give, you can see the light just above me. The electricity that powers this lamp, this light, that this lamp was probably created less than a second ago, right? Because usually the electricity that powers your home is created like instant. It's not stored, right? It's produced, and then right away it is sent into the electricity network. And because electricity travels at the speed of light, even if you live very far from the power plant, the electricity was just produced right now because we can't really store it. So if you want for products that you can hardly store, the only way you can increase supply is increase production. But if so, that and in some cases that might require some time, so that makes you less flexible. So yes, frozen meat, easy to store, even if it can be expensive to store it, because you have to keep a very low temperature in the room, so quite expensive, but not very hard, at least. So in that case, if the price of frozen meat increases, you don't have to produce more to sell more. You simply have to draw on your stock to sell off your inventory. The availability of input, of course, if something becomes more, if you produce something whose price increases, then you want to sell more. Yes, but you might have to produce more. Let's assume you don't have any inventory, you don't have the stock. So the only way you can sell more because you want to, it's more profitable, that's the law of supply, but you need to produce more. And if you want to produce more, you need more resources. So if you actually find more resources, that's great, you can produce more. But what if you don't? If you don't find these resources, you are stuck. You want to produce more, but you are unable to simply because you do not have access to the inputs that you need. And the example that I used, because it was very relevant last year and it is still relevant, is the market for international education, especially in China. If the price of international education in China increases, so basically you have more businesses who are encouraged to open international schools in China. But of course, if we want to open international schools, we need certain resources. And in particular, we need expat teachers, we need international teachers. And you probably know that right now, because of the COVID pandemic, it's very hard for international schools to find international teachers in China. And it's quite interesting now because I hear that some schools are already hiring for next school year, starting in September 2022, because they are very much afraid of not being able to find expat and actually even Chinese teachers, because there is also it's also very difficult to find Chinese teachers who can work in international school in some subjects in particular. But of course, you are economists, so you are smart, so you should wait a little bit, because right now there is still a pretty big pool of workers available. So the balance of power is not in your favor if you want to negotiate your next work contract for next academic year. So you should wait a little bit until the supply of labor decreases a bit, so you become a rare commodity. Of course, yes, the availability of substitutes in production is essentially with the resources that you have. Can you produce many different things, or can you produce just a narrow range of product? Why? Because let's say again you have a field, you have a big field, and so you can produce many things in your field, many different vegetables. If the price of zucchinis rises, what you can do is to use the area of the field that was allocated to the production of other vegetables, salads, tomatoes, things like that, and to produce more zucchinis. So basically, that means that if there are many substitutes in production, it's quite easy to reallocate some of your resources to produce more of the good that has become more profitable. Okay, but if the resources that you have can only be used to produce one good, then you don't have that flexibility, okay, of just reallocating the resources across production processes. But yes, I use the example of strawberries. and raspberries. Essentially, you need the same resources, right, to produce strawberries and raspberries. So if strawberries become less expensive, it's not profitable to produce strawberries anymore. So you're not going to use much of your field to produce strawberries. Instead, you will use this area to produce more raspberries. So it gives you the flexibility to increase your production of the raspberries, a product that has become relatively more profitable. And the last one, the existence of barriers to entry or exit. Why is this the case? Because if the price rises, of course, this will attract many new businesses into the market, or at least they will be willing. If you are a business outside, or if you are someone considering starting a business or entering a market, and you see the price rises, you say, oh, wow, this means that this market is more profitable. I want to enter, I want to start a business in this market. And if you can do that, then you will actually enter the market, produce more, and overall the market supply will increase. Yes, but you might be prevented from entering the market. This could be because of natural barriers, could be because of legal barriers. In that case, even if the price of the output is higher in the market, you want to enter and contribute to an increase in the quantity supplied. But if you cannot break down the barriers to entry and actually join the pool of suppliers, then the market quantity supplied will not increase significantly. So I use the example of aircraft because it's a typical example where there are very, very high barriers to entry. And there are actually right now just two suppliers, Boeing and Airbus. So I know that there is a Chinese company that is trying to compete with them, but at the moment it's only two. So even if the price of aircrafts increases a lot, then the supply is not likely to increase by much, simply because it's going to be very, very hard for new businesses to enter this particular market. And finally, of course, one exercise again to calculate a price elasticity of supply to determine whether the supply is relatively elastic or not. And that is it. I am done finally. So you see, we've done all elasticities. Don't rush this content because, again, look at the past papers. Every year, almost, there is one essay question about elasticities. So, and I think it's usually an easy essay question, especially because it is very predictable. So if your students know this PPT very well, they should really approach the exam and with a high level of confidence. Any questions? I hope you found this tonight's event useful. I hope this has helped you to gain confidence when teaching this topic. And again, I will share the summary. I will share the summary of this topic on elasticities, probably Friday. I think I have a very busy day tomorrow, so I don't think I'll have time to do it. So probably Friday, if not Saturday. Okay, so just come back, just have a look at the website in 2 days, and you should find these documents. Any questions? Any remark? Any feedback? Anything? So just before we conclude this this video, so for you guys and for all those watching the video recording, please keep in mind that it's likely that there will not be workshops for AS macroeconomics, simply because I was really hoping that for each workshop I could at least find 30 teachers interested in the events, and it's not the case. So for me, it takes a very, very long time to prepare these events. Yeah, I was hoping that at least I could have the events fully booked, so I can at least cover the opportunity cost of my time. Right now, this is not the case. So for AS, of course, I will continue until the end of the microeconomic part of the syllabus, but unless unless I can find enough teachers to attend these workshops, I will not schedule workshops for for the macro part of the syllabus. An increase in price, this all depends on how elastic the demand is, right? And I don't really feel comfortable increasing the price because I would assume that for most of you guys, it's no big deal if I increase the price a little bit, but I can't assume that this is true for everyone. And I don't want these workshops to represent a big expense for teachers. This is something that you pay from your own pockets, I assume, most of the time. At least it's not financed by the school. Yeah, so I'll see. It will depend on whether the next workshops can be fully booked or not. But if it's not the case, I will focus on the A2 workshops, which are almost fully booked all the time. Okay, but again, thank you guys for joining live tonight. I would have felt very lonely if you were not there. So thanks again. That really makes a big difference to me, a positive difference to me, of course. And I wish you a nice evening. And next week, we will talk about market equilibrium, the consumer surplus, the price mechanism. So these are very important topics. And I hope that this will, again, help you to gain confidence when going through these topics with your students. Have a nice evening, everyone. Talk to you soon. Bye-bye.